Welcome to this explainer. Before a computer was a sleek little machine sitting right there on your desk, and honestly, long before it was an electronic gadget at all, it was actually a job title, and it was a job held by real flesh and blood human beings. Today, we're diving into the incredible story of the women who quietly powered some of the absolute biggest scientific and military achievements in modern history. This is the hidden workforce that literally laid the groundwork for the digital age we're all living in today, way before silicon chips were even a blip on the radar.
Okay, let's dive right into this. When we ask what a computer was before the machine, the answer is pretty mind-blowing. We are talking about massive rooms filled with people, and specifically, almost entirely women. Just imagine walking into one of these rooms back in the day. The air is just thick with intense focus. Literally, all you'd hear is the rapid scratching of hundreds of pencils on graph paper, mixed with the heavy metallic clacking of those early mechanical adding machines. You've got dozens of women sitting side by side, grinding through unbelievably complex mathematical equations completely by hand. We're talking 8, 10, maybe even 12 hours a day. They were essentially the biological processors of their era, taking all this raw data and churning out the actual numbers that built the modern world.
So, by its original definition, a computer was quite simply just a person who computes. Somebody whose entire professional existence was dedicated to doing massive, complicated math problems by hand. And let me be really clear here, these were not your average high school algebra problems. A single equation could take days or even weeks of continuous, grueling calculation just to solve. And the math these women were doing handwritten, it was absolutely vital. They helped design warships, painstakingly tracing the exact curvature of the hulls just to make sure they wouldn't capsize in the water. They calculated artillery trajectories during wartime. They even helped figure out how to launch the very first astronauts into space. Science and engineering back then just required a volume of precise math that was way beyond what a single engineer could ever pull off alone, so the only viable solution was to hire vast teams of full-time human computers.
Now for part 2, why women ran the numbers and the economics of the job. From the late 1800s straight through to the mid-1900s, employers desperately needed a mountain of calculations done, and they found a very specific workforce to fill that growing need.
You see, during this era, there was a stark, almost glaring contrast in the professional scientific world. The traditional male engineer was highly valued, given a standard career path, and paid a premium salary. Meanwhile, female computers were systematically shut out of traditional STEM careers. Even if a woman had a brilliant mathematical mind and a university degree, the societal norms of the time pretty much barred her from ever holding the title of engineer or scientist. They had this genuine, extraordinary talent, but nowhere to use it in the traditional establishment. But at the same exact time, employers, everyone from astronomy observatories to the military, had this massive demand for detailed, repetitive calculation work. And they quickly realized a rather harsh economic loophole. Hiring mathematically brilliant women for this specialized labor was significantly cheaper than hiring men for the exact same tasks. It was an exploitative economic reality, for sure, but it inadvertently created an environment where human computing became one of the very first major technical professions where women were actually the clear majority.
Moving on to part 3, math that changed history, and the massive stakes of these calculations. So what exactly did they spend their days doing with just pencil, paper, and those loud mechanical adding machines?
Well, their critical calculations generally fell into 3 main pillars. First, astronomy. Early human computers calculated star positions and complex planetary data that fundamentally advanced our understanding of navigation and the universe itself. Then there was the military. Especially during World War II, they were the ones calculating artillery trajectories. Just think about how staggering that is for a second, aiming weapons over incredibly long distances by manually calculating wind resistance, distance, air density, and target movement entirely by hand. And finally, aerospace. They performed the unbelievably complex orbital mechanics necessary for early rocket design. And this brilliantly illustrates the absolutely massive stakes of their work. A single uncorrected mistake in a firing table or a rocket trajectory could have dire real-world consequences. We're talking costing lives or completely destroying a mission. So to prevent this, they used really rigorous cross-checking. 2 different women would be given the exact same massive equation to solve completely independently, and only if both arrived at the exact same answer was the math considered verified. Talk about requiring intense, unbreakable focus.
Which brings us to our next section. NASA and Hidden Figures, the climax of the space race. This is really where this history connects directly to some of America's most iconic achievements, powered by teams of human computers, including an incredible group of brilliant black women at NASA and NACA.
The year is 1962, and the geopolitical stakes literally could not be any higher.
The United States is locked in a massive, incredibly tense space race against the Soviet Union, right at the peak of the Cold War. The Soviets have already managed to put a man in space, and the pressure on America to successfully pull off an orbital spaceflight with astronaut John Glenn is just overwhelming. Every single little detail, the orbital trajectories, the incredibly tight launch windows, the exact re-entry flight paths, it all relied on the math being absolutely flawlessly perfect. Now, early room-sized electronic computing machines were just starting to be introduced to handle these formulas, but right before launch, there was this profound moment of human trust.
Astronaut John Glenn was actually so famously skeptical of those new electronic computing machines that he point-blank refused to fly until one specific person stepped in. He explicitly requested that Katherine Johnson, one of the incredibly brilliant black human computers at NASA, personally verify the machine's orbital calculations by hand. He basically wasn't willing to strap into a rocket and launch into the literal vacuum of space until she ran the numbers on her desk and confirmed they were good to go. Glenn personally trusted her handwritten, meticulously cross-checked math over the output of a multi-million-dollar early electronic computer. How amazing is that?
But we really can't tell this whole story without looking at the next part, the hidden obstacles and the brilliance amidst injustice. Because despite essentially enabling the future of modern science and spaceflight, these women face severe societal and professional roadblocks every single day. The systemic barriers they faced were just stark. Even though they were performing highly skilled, completely critical work that literally launched men into space, human computers were frequently paid significantly less than the male engineers doing comparable technical roles. On top of that, no matter how much sheer mathematical genius they demonstrated day in and day out, they were largely denied advancement into any sort of higher scientific or engineering leadership positions. And perhaps most egregiously, during the mid-20th century, black human computers faced intense systemic racial segregation. At NASA's Langley Research Center, women in the West Area Computing Unit were forced to work, eat, and use restrooms in completely segregated facilities entirely separate from their white colleagues. They endured these profound indignities all while performing identical, mission-critical work that the entire nation depended on. It's a really sobering reminder of the immense brilliance and incredible resilience these women displayed.
Moving into our final chapter, the electronic transition, shifting from human to machine. Eventually, when electronic computing machines arrived in the 1950s and 60s, a huge shift happened. But these brilliant women didn't just disappear. If we look chronologically across the 19th and 20th centuries, we see this really fascinating evolution. The 1800s saw the rise of these human computing teams out of pure necessity. But as we move into the 1960s, things change. Instead of just losing their jobs to the newly introduced mainframes, many of these former human computers actually transitioned directly into early software programming. And when you think about it, why wouldn't they? They were the only ones who actually intimately understood the complex math the machines were trying to execute. They took their deep analytical expertise and essentially laid down the principles of early programming, verifying and cross-checking the computer-generated outputs. Katherine Johnson herself kept contributing her brilliant mind to NASA's space program well into this new electronic era. In fact, it wasn't really until the 1970s that the word computer shifted entirely in our cultural vocabulary to mean the machine itself, effectively retiring the human job title to history.
So I want to leave you with this final question to think about. If machines took their title, how will we remember the women who actually built our future? The human computers might be gone as a profession, but their legacy is permanently embedded in absolutely everything, from wartime defense to our very first footsteps in the cosmos. Long before that machine sitting on your desk earned its name, it was barrier-breaking women who quietly powered the major breakthroughs of the 20th century. Definitely something to think about the next time you open your laptop. Thanks for joining me on this explainer, and keep questioning the history behind the world we live in today.